So, hello everyone, welcome to another video. So, in this video, we will dedicate all our time in the introduction part of Dart. We'll check like how to run the Dart code and what are the basic things. We'll also discuss what are objects, classes, functions, all those things. Yeah. So, in the last video, we checked about the widgets, the types of widgets, stateless widgets, stateful widgets. We also looked at the source code also, code snippet for how to implement stateful widgets, how to implement stateless widget. We also checked the difference between them and the build function. And and at the last, we tried two more code snippets regarding a single widgets. We tried with like two widgets, and then we made a complex code where we used multiple widgets. Okay, and that is sometimes called as composition. So first of all, you might be thinking about this question like, why Dart? We are here for app development. We need to learn Flutter and all those things. So why we are learning Dart? So Flutter is a framework, and Dart is the programming language that is behind it. Okay. So I know there are widgets. We can basically use widgets and for creating text, rows, columns, and we have containers. But at the end, at the very core, we are still writing the code in Dart. Okay, so many of you might not be, but might be this is your first time for any programming language. So you don't have any idea about how to write a programming language. So that's why we are thinking like, why don't we start from the pretty basics about like what are how to write code, how to print something, how to create a variable, what is a constant, how to assign a value or a name to a character, or what is the use of the syntax, where, what is indentation, why we import, why we write main functions, all of those things. Okay, so some of the good things about Dart is like it is like object oriented. Okay, so with that, with the help of that, we can use classes, we can use functions, we can use inheritance, oops concept. And in the last video also, we were using syntax or words like keywords like extend and words like classes, override. So those also comes in the like object-oriented programming systems. Okay. Now we'll also start with the pretty basic implementation of that. Okay, and as I said, like Flutter is just a framework and language behind it is Dart. So if you don't have any idea about Dart or any idea about programming language, then this is the best video of this course. Okay, so the good thing about Flutter last that we discussed in the last video also, like Dart is the one and only language for Flutter. It means for front end, for UI, UX, backend, only thing you need to learn is Dart. Regarding other programming languages like web development, app development, you basically used to have learn various languages. For web, you have to learn HTML, CSS for the front end, and then for the backend part, you have to go for other frameworks like JavaScript, languages like JavaScript, you have to learn React. And similarly, when we are doing app development with the XML files, you have to for the UI part, we have XML, and then for creating the logic, for writing the code, we go with Java. Yeah, okay, so that's it. So that's once again a plus point about Flutter is that you only need to learn Dart, only and only programming language for Flutter. Okay, because Flutter is a single code based framework. So which means for front end, for UI part, and it's also for the backend part. This is logic building. Okay, we want to create any functions, we want to write our logic, right? Because most of the time we are building for our own purpose, and then if it fits good to you, then you can publish it, no worries. And if you are done with like pretty smooth, if you are very pretty smooth with that, then you can start with Flutter codes. And if you can learn that, then everything is like pretty easy. Okay, the syntax, will look at the syntax. So as I said, like basic features is object oriented. It follows OOPS concept. And there is one more feature that is like async and await. Okay, so you can use functions like async and await that comes under like asynchronous program. Now, what do you mean by asynchronous programming? So, so it's mostly about like the multi-threading. Okay, just look at like there is a pretty big task in your source code, and we are not aware of like how much time it will take. If it's like a pretty large task, then I don't want all of my resources to waste to take time for the simple task. I want multiple tasks to run. Okay, so this task will go on and parallelly will use other tasks also. Okay, so there's like parallel computing. There are multi-threading. There are multiple threadings. Okay, whenever you buy a laptop, you say like 6 core, 12 threads, 8 cores, this many threads. So these threads are for like multiple programming, parallel programming. Okay, if you want, and that's why we use like async and await. Cool. And later in this course, I will also use this async and await functions. Okay. And if you want, I can show you also about this. Let's just cross this. Asynchronous programming. Cool. So it says like asynchronous programming is a technique that enables the program to start a potentially long running task, and still be able to be responsive to other events while that task runs rather than having it to wait until the task is finished. Okay, if we look at the images, this is like updating one task is in this and like this request response. And similarly, this is the asynchronous synchronous. Okay, so asynchronous by synchronous, I mean like okay, there are two variables like there's a name, okay, and in name you have given you are taking for input from the user. Okay, so you write enter your name, and then at that time you have to wait for the user to enter the name. And once that end will say like where where full name equals to name which was on the first line, name plus something else. So the second thing is depending on the first thing. Okay, like in this case, the request and response. The first thing is depending on the next thing. This is like synchronous when we have to wait, otherwise it will not run. But asynchronous is like parallel. Request one, response one. So all the tasks are going parallel. Main thread, and there are like multiple threads running also. Synchronous and asynchronous. That's it. So, and if you want, we can also look at those examples future later in this video also. Okay, let's go back. So that's all about like what is the features of. And one more pretty important feature about Dart is like it it is like compiled using both JIT as well as like AOT. So what is JIT? Like just in time compiler, and the other thing is ahead of time compiler. Okay, now there's a very big difference between these two compilation processes. So basically, when we use JIT, okay, so just as it name says, just in time compiler. So while running the program, it compiles. Okay, so when you are like working on a development environment, you want to check, okay, this thing has been I want to check like I'll change the code regularly, and on the real time cases I want to see the output. What is the output of the changes I've made? Okay, so that time we need just in time compiler. Okay, and then we have ahead of time compiler. So whenever your product is ready, I mean your application is ready and if completely ready and completely built. And if you want to give or if you want to show this app to your clients or to someone, to your friends, to your boss, then at that time you'll do it completely compiled using ahead of time compile. Okay, so what ahead of time in compiler is like mostly for the production. Okay, once you're building and once you're experimenting, then it's completely ready. Then we can use ahead of time compiler. Now, what does ahead of time compiler does is like it compiles the whole source code while building the program. Okay, it says ahead of time. And the difference with GIT, it was like building and compiling. It was compiling at the real time. Okay, when the program is executing or program is running, at that time it compiles. Now, if so, I want to go a little bit deep in this because it is like an important topic. And regarding compilation, GIT, you must have heard about this in Java also, because Java also supports just-in-time compile. And Dart is like one of the like very few language that is well suited to being compiled with AOT and just-in-time. Okay, now let's discuss about like AOT. First of all, let's discuss about how the compilation process works. Okay, so you have written source of code. Okay, you have source of code. Okay, firstly I'll explain, then I'll go to Google to check out some of the images. So first of all, like there's a source code and you start compiling it. Okay, so earlier what used to be done, like in the aid of time compiler, you are compiling the source code and it is converting to an intermediate language. Okay, an intermediate code. So when you compile using any compiler, the source code is compiled to an intermediate code, or you can also sometimes it creates assembly code. Okay, so what it does, like source code is converted into assembly code. Now since we have assembly code, it is still not like the actual machine code that needs to be executed on CPU. It's like the intermediate code. So that's why I'm saying like assembly code. Now that assembly code is passed to the assembly. Okay, let's just write it here. Now compiler, then it goes to assembler. Okay, and because we have assembly code. Okay, and after this assembling code, that intermediate code is passed to assembler, then this assembler pass the code to the link. Okay, it passes to the linker, and this linker, like it is mainly important for, and this assembler will, yeah, this assembler will this- it will convert it to the machine code. So the assembly code. So first of all, it was like source code to assembly code, also known as intermediate code. Then we passes it to assembler. Then assembler creates the machine code. Okay, so this is not completely related to app development, but this is like one of the important thing. Even if you study operating system in your college, mainly in your computer science, then this part is pretty important. Okay, because we compile throughout a whole day, like we compile it daily throughout the year, throughout the days, throughout the minutes. And if you don't know the process of compiling, then it's kind of sad because like you are blindly compiling and you actually don't understand what compiler does, what is this compilation process, how much memory it takes. Then it's like a complete waste. Okay, so you are just blindly following this course. You're not understanding what this compiler does and those things. Then it's not the correct way according to. Okay, so that's why I personally wanted to take more time on this part. Yeah. So source code is converted into the assembly code, then it passes to assembler, then assembler creates the machine code. Then it passes to the linker. Now what linker does? It likes the, let us suppose like you have external libraries in your source code, external files, functions that are like chained, they are linked. So all those external libraries, all those function chaining will be done by the linker. Okay, so linker will create a layer above it. And then finally, we have a loader. Okay. loader loads the all this machine code is into the memory. So it take cares of the code that whether it goes to the memory or not. And once it is on the memory, then the final done is CPU. CPU will execute the code. Okay. Now this is how a complete program runs. Okay. And once it is in the memory, then it like a process, then it is executable. CPU, or you then call it processor. This is like the complete process how your program runs. And we can say this is like the ahead of time compilation because you are compiling the whole code. Okay. Now, now, yeah, most programming language follow this, but nowadays we don't have like assembler and linker because most of the things are done by the compiler itself nowadays, like C, C++. So they follow this architecture. In that case, I guess the assembler is not there. Still, assembler and link are not there, but compiler itself works like it has the progress. I mean, it has the options for being perform these functions, right? So now this is like ahead of time compilation. Okay, like processing while building, you are just building and like compilation are done together. And then we have like the just-in-time compiler, like what JIT is. So just-in-time compiler is pretty different, and you know about the fast hard reload, okay? So behind this like fast hard reload, the key thing behind it is JIT, just-in-time compiler. So when we compile using JIT, the architecture is completely a bit different because at that time we have compiler. Okay, then compiler will create bytecodes. Okay, it it does not create the machine code directly. It creates bytecode. Okay, and this bytecode, okay, this bytecode, like it is also like this bytecode is like then interpreted by the Dart VM. Okay. Not if you are like in Java, then JVM, Java Virtual Machine. In this case, we have Dart VM. So it will interpret the bytecode. By interpret, I means like run, read, and execute. So most of the things are not directly done by CPU this time. Okay. Now the most of the things are done by Dart VM this just in time, compile. Okay, since Dart VM will interpret the bytecode. Okay, and then finally what it does, then this just JIT compiler what it does is like it searches for hot paths. By hot paths I mean like it will like follow some of the procedures to check which part of the program, which part of the bytecode is executed frequently and is changed frequently. Okay, because not completely we are not completing the whole program, we are not compiling the whole program altogether. Okay, so it just like because we change directly, so while running we are building, that's not the case here. So it will check which part of the bytecode. So in last video you checked like we were changing I have pressed, I have clicked, I have typed, so we were changing this part again and again and again. So this part, so this JIT, just in time compiler, will check, okay, this part is changing again and again, this part is executed again and again. So this path, why don't I do one thing? Why don't I give this once again compile this part, okay, and I'll create the machine compiling this part, JIT compiling, we'll call it JIT compiling, and give this part and and compile it, and then we'll just type doing machine code and then give it to CPU, give it to memory using loader, and then CPU will execute it. Okay, so you can see the most of the things are like done by Dart VM. Earlier in the AOT, all the thing was done by CPU. All the machine code was done by. Right now, the compiler will create bytecode, then will interpret it by Dart VM. Then it will once again do. It won't compile the whole source code once again. So because whole source code is like executed in the Dart VM itself by the GIT compiler. Okay, not by the CPU processor. Not it will not executed on directly by the CPU, not computed executed on the CPU. This complete thing will be done by GIT compiler. Okay, and then not whole part will be converted into machine code for the CPU. Only the hot paths. By hot paths, I mean the frequent bytecode which is being executed, which is being changed. Okay, a specific part of it. That's why, and like that's why this what it will do for the hot reload part. Okay, I'm changing. I have clicked. I have pressed. I was doing it on the second video, on the third video probably. So that part will be compiled into machine code once again, and then machine code will be given to CPU. Now this part will become very fast. Okay, this compiling, this execution through CPU is always fast as compared to GIT, the Dart VM itself, because at the end of machine code will execute fast on run. Although the whole process of compiling of ahead of time compiler is like in comparison to GIT is slow because we have to compile the whole source code. We're not just compiling on the real time. Okay, we are changing this. Let's recompile. We're not doing this. We are not compiling the whole thing in the JIT compiler. That's why JIT compiler is fast. But for the features like hot reload, JIT compiler, the hot paths will be converted into machine code, and machine code will be executed by CPU. So only for the specific part, it is creating the machine code. That's why this hot reload thing is very fast. Okay, I guess that makes any sense. Yeah, and that's is like the pretty difference between like what AOT and JIT does. Okay, and similarly, there are some other things that I want to discuss once again. So .vm is already done, JIT is done, and looks like execution is binary is done. Yeah, so basically this is what's the main difference between JIT and this AOT and stuff. And why developers like at the creation and the development process they directly go for the JIT just in time compiler because they don't want to recompile the whole source code. They don't want to compile the whole source code because they want to do changes. They want to see what's the reply of the request. Okay, that is why they definitely go for the JIT. But once the program is done, the app is created completely. Then at that time, we definitely go for the AUT. So just for summary, okay. So in the JIT process, the source code is first compiled to bytecode. When you run the program, the Dart VM interprets this bytecode. During execution, the frequently executed parts of the bytecode are JIT compiled into machine code. Not complete, not whole bytecode, only the frequently executed part of the bytecode are JIT compiled into native machine code to speed up their execution. Okay, this machine code is then executed directly by the CPU, and there's this loader's role is to ensure that necessary part of the program are loaded into memory or the CPU for the CPU to execute. Okay, and the JIT kicks in for the part where we basically say that code on the fly sections like it executed bytecode sections into native machine code on the fly during the program execution only. Okay, not before the execution, during the execution. This is done to speed up the execution of hot paths. And one more interesting thing about JIT compiler is like this machine code is like cached. Okay, like L1 cache, L2 cache, L3 cache. This cache is very fast. Okay, so this machine code is cached. So if the same section of the code is executed again, then the Dart VM can directly use the cached machine code instead of interpreting the bytecode or recompiling. Okay, that's why once again this why hot reload is so fast because the machine code is cached. So okay, and that's like the pretty deep difference between JIT and AOT. Because personally, I think these topics are really important. Okay, I won't take much of your time. Let's directly jump into VS Code to introduce with the syntax into the code of Dart. Okay, so I've created this folder once again. This is let's open it on terminal. Okay, cool. And let's type CODE to open the VS Code. Okay, so the VS Code is opened. Let's create a new file. Let's say it Rahul dot extension is done. Okay, so this thing is done. So before writing anything, I want to make sure that you do these changes. Click on this manage button, click on the settings. Okay, click on the settings, and then you'll have to type terminal. Okay, so you'll have to write terminal and then come to the dot part, and in the run in SDK paths, you'll earlier it will be debug console by default, but you'll have to click on terminal. Okay, so the most of the things that are executed or that are showed in the terminal part. Okay, so this part is done. Setting is done, and you can turn on the settings sync if you want. But this is the roll.dot part. Okay, so let's create a normal, like the basic thing that we do in programming languages. Hello world. Let's create a hello world program using that. Okay, so first of all, we'll create the main function. Everything in like even in C++, there's Java, everything starts with this main function. Okay, without this main function, your program cannot be run. Okay, so this is where your execution, your even the compilation start from this line. Okay, this is like the entry gate of the execution. Okay, this is the void main. Main is the name of the function. Okay, later I'll tell you what a function is, but this is the function. Function is like the collection of set of codes. Okay, rather than writing codes once again and again, you are using a function. Okay, let's like you do. Okay, I'll have two number 2 plus 2. It will be 4. Then once again I'll give two more numbers like 4 plus 4, 6. So instead of writing this again and again, I have an idea. Why don't I create a function called addition and I'll provide these values to him and he will give the output. No more, no more like headache about give the number, then add it again and again and again. I just have a function, give these numbers to the function and it will go to output. Okay, similarly, this is the main function. Its role is not to do the addition, but its main is like to start the program. And void is like void tells you that okay, it won't return anything. Okay, but this function will not return anything. So for printing the hello world, you don't need to do much of the things. Just type print bracket hello hello world. Okay, and then you have this semicolon. This is the syntax. Like for ending a statement, you write colon semicolon. Even in C++ and even in Java, we do these things. Okay, so let's save this program. I hope you have like already done changes in the settings to open the terminal. Click on this option and let's run. Okay, so you can see the output. It says hello world. Good. It is saying hello. Okay. Similarly, you can write anything. Hello world. Once again, print. Say I am Rahul. S and run once again. Hello world, I am Rahul. Cool. Similarly print. So it's like Python only. Only this print function is like Python. Although we say like Dart is like the mixture of uh, C sharp, JavaScript, and uh, and yeah, JavaScript and C sharp and all those things. Okay, and but this print option is like similar to the Python one. Although all the other things are like different. Even some of the components look like C++ plus plus also. So print once again. I hope it's you are able to understand this. Print. I am a man. I am I'm a man. Control, not control S. Full. Control S. Let's run it once again. So we can see three lines. Hello world, I am a Rahul and I'm a man. That's it. Now instead of writing print, you can do one more thing that is like std out. And wow, the magic happened. So you as soon as I type this std out, you can see this import function is import is there. And it is like importing the library of Dart and also this IO library. And this IO library is mainly for the input and output. And even you can see like file socket, HTTP, input output support. It performs these various things. Browser-based apps can use this library. Okay, no problem. This is how it is done. Using std out and using std out, we will write something, we'll print something. In print, I'll say I evolved this. Okay, I evolved. And at the end, we have semicolon. Control S. And here it is. You can see I evolved. Okay, if you want to clear all these things, you just like CLS. It is clear. Okay, now, okay, what the printing is fine, the output is fine. Now, how about I give arguments on the terminal? How about I type in something? Okay, not here, but in this output icon, in this terminal icon. So let us say we do one thing. I tell the user to enter your age. Okay. So std outright is done. And let's say one thing. Let's ask for the input from the user. So we'll see std in, sorry, std in dot. We'll do some of the things like read line sync. Okay. And in read line sync, this is the function that will like ask for the input. Okay. So let's run this command. So, so it's asking for enter your age. Let's suppose I am 100 years old. Done. Okay. So it asks for my age. I typed 100. Okay. Now this is fine. This is how we input. We take input from the user. Okay, but 100 is fine, but it's not printing like your age is 100. Okay. Let's do one thing. Let's assign the value of this read line sync to a variable. Okay. So we'll say var, and I'll call it age and age and assignable. Now, whatever you take the input is assigned to this variable. Okay. So whatever you type here, like 100, 200, 50, 27, 14, 12, 13, 1, whatever you type, it will go inside this variable. Now, this age is just a name. It's just a name of the variable. Okay. Like you have written a book like The Monk Who Sold His Ferrari. Okay. The monk who sold his Ferrari is like the value, the input. But what is this? It is a book. So that's why it is a age book. Age and book are just a variable. Inside this variable, we have assigned a value. Like in age, I'll give it 100, 200. Like similarly to a book, I'll give it the name, the mongoose sold is Farah. So just like that, age is just a variable. And that's why it is also telling that, okay, whatever you written age, it's a variable. If you remove this part, it will give error like undefined name. Try correcting the name to one that is defined. So this where is predefined. So when we get, okay, so this is age is a variable, okay? Because the machine, the VS Code doesn't know what is the age. It doesn't have any idea about it, right? We'll tell the machine, we'll tell VS Code, we'll tell the system that where this age is a variable, okay? And inside that variable, that is age, we'll provide some of the values. Using std, we'll take some of the inputs. And right now it is giving like the value of the local variable age isn't used. So it is saying that okay, you have taken the input, but where it is getting used? Nowhere. Okay, but we'll use it now. We'll print something. Steady out, right? We'll say your age is X. Your age is, what is your age? So this age is given to this value, this variable. So I'll do it age. Is that correct? Yes, somehow it is correct, but like age is like only the sentence. Okay, how we are getting the value of that value that is assigned to this age? For that, we'll have to type this dollar sign. And even if you use like Linux also sometimes we have to write dollar to get the value and assign it to a variables. Okay, it is saying age. Now you can see even the color is different. So your age is slightly different from the age because is in age is just not writing an not writing a normal statement, but it is taking the value that is assigned to this age, which will be taken input from the terminal using this readline sync std. Okay, this is the age and scroll finish. Control S. Let's wait for the output. We'll run the command. Once again, it is asking for age. This time I'll say it. My age is 200. Okay, although it's not possible unless you are an elf, I guess, because it is not for them. 200. Oh, wow. So you can see the magic happened here. It says your age is 200. Your age is 200. If I would have written only age, control S, even something like your age is age. Because I've just written age. I'm not providing any value to this. Once again, I'll write it dollar, control S. Once again, I'll just not clear the terminal. It's 200. So you can see the difference. Okay, what a simple symbol is like creating a whole massive difference. Because that's how like programming works. That's how code works. Okay. Now this is like the easiest part of the code. We'll also write some of the complex code later in this course. And then finally we'll use all the widgets, all the Flutter, rows, columns, all those things to create a beautiful app for you. We'll deploy it using an app emulator or even with a real physical device. Okay. So let's change some things. Like it is saying enter right now we'll call it enter your name. Okay. Now once again, now we should why don't we even like right now it's saying age. Earlier it was asking for age. So right now we have assigned a variable with the name age. So but right now we are not wanting any age. That's fine. That's completely fine. You can even write name here, but that's completely fine because you have told the machine that age is a variable. Now, no matter what you give to this variable, it's completely up to you. I don't have any relation with this variable. It will only saying you, okay, you take care of this variable. So okay, once again we'll save it just like that and enter your name. I'll tell Rahul. Whoa, your age is Rahul. But I did a mistake. Instead of age, let's put name. Even though it is name, but we are assigning the variable age here. So your name is Rahul. Name is Rahul. Easy. You see these magical things, how programming works? Programming is very easy, very literally. The easiest thing you can do is like write a program. And once you are like perfect with a single programming language, then you can learn, seriously, you can learn any programming language. Most of the people say like, oh, uh, you have studied Python, you have studied C++, then you will, okay, they studied like for 4 months to learn a single programming language. Then they are also again, once again, on the next semester, they are learning another programming language for whole 4 months. So it doesn't work this way. Once you are familiar with programming language, the concept, the syntax. So this is called the syntax. There's like a the particular pattern that we have to follow. Like we have to always run void. These are some of the rules. We have to we have to end a statement with this colon. So these are some of the rules, and these rules are called like syntax. Okay, is how the color of var is different because it is predefined. How the color of void is different because it is predefined. Why the color of blue is this, and why our input is like this. Okay, let's change the age to name, although it won't have any problem itself. Right now, if you'll, okay, so if you do something like this, it will give error because we are asking for an age and we have not defined what age is, undefined. So it will give debug again. So it's like undefined name. Okay, so let's change it to name, s, and once again, run this. Enter your name, Rahul. See, so even though we made several changes here, but the output is same. No matter what variable you provide, the output is same. This is how we play with programming language. Very easy concept, very easiest thing you can do is like this. Okay, so this is like the introduction of Dart. Later in the next video, we'll see like more intermediate things like what are functions, how to create a loop, how to compare something, how to conditional loops are there, how to create conditional statements, all those things. So right now it's like the pretty easiest thing. And you can similarly will import some other libraries also based on a use cases what libraries we want to use. Right now it was a single input output thing. That's why we are using this dart io for std out printing, std in for like taking the inputs. That's it. Okay, so we'll do a quick recap. Quick recap is this compiler part is done and the introduction to Dart is done. We change looked at the hello world program done. Dart IO library imported, taken inputs and done, and what to say age and name program. Yeah. Okay. So in the next video, we'll talk about some other things that I already discussed, like functions, variables. What is the meaning of constant and integers and strings and functional, conditional, iterative loops, all those things. Okay, so that was it for this video. See you again in the next video. Thanks.